Hello guys! I'm going to introduce myself. My name is Eka Laloan.
Hello, my name is Beatrix Rondonuwu.
Okay guys, I want to introduce myself. My name is Noviantika Nebath.
Unnecessary forms and roles of alphabetical. Unnecessary forms. A. Unnecessary forms, that is 0 over 0 and infinite over infinite. B. Alphabetical rules. C. Unnecessary forms, that is 0, infinite, infinite minus infinite, 0 power 0, infinite power 0, and 1 power infinite. A. Unnecessary forms colon 0 over 0 and infinite over infinite. The first point, unnecessary forms 0 over 0. Definition: if f and g vacations such as colon limit x approaches 0, fx over gx with limit x approaches 0, fx equals 0 and limit x approaches 0, gx equals 0. Vacation defined by fx over gx known as having an unnecessary form 0 over 0. This is called an unnecessary form of 0 over 0 because we cannot make sure that he or she will go to infinite or he will go to 0. So there are two interesting or opposite forms of mutual interaction. Example: number 1, limit x approaching 0 sin x over x equals 1 hasn't been using the L'Hopital rule. Number 2, limit x approaching 1, x squared minus 1 over x squared plus 5x minus 6 equals 0 over 0 hasn't been using the L'Hopital rule. The second point, a necessary form infinite over infinite. Definition: colon and limit x approaching 0, fx over gx, if limit x approaching 0, absolute fx equals infinite, limit x approaching 0, absolute gx equals infinite, then limit x approaching 0, fx over gx called having an unnecessary form infinite over infinite. Then the vacation defined by fx over gx is called having an indefinable form infinite over infinite. This is called an indefinable form of infinite over infinite because we cannot make sure that he will go to infinite or he will go to 0. So there are two forms that attract interesting or opposite. Example: colon limit x approaching infinite x cubed over a power x equals infinite over infinite hasn't been using the L'Hopital rule.
L'Hopital rules. This rule was introduced by Guillaume Anthony de L'Hopital in 1696 in a book, which he retrieved from his teacher is Johann Bernoulli. Next, theorem of L'Hopital rules are not necessarily 0 over 0. Suppose limit is interpreted for one of these symbols: limit x opposing a, limit x opposing a min, limit x opposing a plus, limit x opposing min infinity, or limit x in opposing infinity. points from limit fx is equal to 0 and limit gx is equal to 0 when limit f action x over g action x exceeds either he is infinity or infinity, because so the number is up to L, infinity or mean infinity. So then limit fx over gx is limit f action x over g action x. Okay, next example. Limit x approaching 0 sin x over x. The first we must prove in advance that is from 0 over 0. So limit x approaching 0 sin x over x, we ask L'Hopital rules. So limit x approaching 0 sin x derivative of sin x is cos x and x is 1. Limit x approaching 0 cos x over 1 is 1 over 1 is 1. So the final result from limit x approaching 0 sin x over x is 1. Next, theorem of L'Hopital rules are not necessarily infinity over infinity. Suppose from limit is interpreted from one of these symbols is x approaching a, limit x approaching a mean, limit x approaching a plus, limit x approaching mean infinity, or limit x approaching infinity. Suppose from limit absolute fx is equal to infinity and limit absolute gx is equal to infinity, because when limit f action x over g action x excited, either he is infinity or infinity. So the number is up to L, infinity or mean infinity. And then limit fx over gx is limit f action x over g action x. Okay, straight to example. Limit x approaching infinity x cube 3 over e cube x. First, we must prove infinity over infinity. Next, we ask the L'Hopital rule for this. So limit x approaching infinity x cube 3 is 3 x squared over e cube x. Then limit x approaching infinity, so 6x over e cube x. And then final result from limit x approaching infinity x cube 3 over ex is equal to 6 over e cube x is 0.
Other forms of unnecessarily. Unnecessarily forms 0 times infinite, infinite minus infinite, 0 to the power of 0, infinite to the power of 0, and 1 to the power of infinite. In addition to forms 0 per 0 and infinite per infinite, there are also used unnecessarily forms like 0 times infinite, infinite minus infinite, 0 to the power of 0, infinite to the power of 0, and 1 to the power of infinite. And everything can be solved using the rules L'Hopital, after which the forms are converted into a form 0 per 0 or infinite per infinite. There are many other possibilities such as 0 per infinite, infinite per 0, infinite plus infinite, infinite times infinite, 0 to the power of infinite, and infinite to the power of infinite. Not to be called an unnecessarily forms because in each case, the strange help each other, not complete. Form 0 times infinite and infinite minus infinite. First, 0 times infinite. Limit fx times gx as x approach to u with fx is infinite and gx is 0. For the example, limit tangan x times ln sin x as x approach to p per 2 with limit tangan x as x approach to p per 2 is infinite and limit ln sin x as x approach to p per 2 is 0. Then we use the L'Hopital rules so you can see the solution at the slide. Second, infinite minus infinite. Limit fx times gx as x approach to u with fx is infinite and gx is infinite. For example, limit 1 per sin x minus 1 per x as x approach to 0. So you can see the solution at the slide.